Yes, sir.
Grouping of cells. So first one we will discuss about series grouping. Series grouping, we connect positive terminal. This is positive, this is negative. So again, positive terminal, negative terminal to positive terminal, so on like this.
Yes, sir.
We'll connect one resistor whose resistance is R. Let us take this as E1, E2, this as E3, so on.
Yes,
Okay. Now the current I is flowing through this.
yes,
Now
sir.
n identical. So if you put n identical cells in series, first case is n identical. N identical cells, I've connected them in series.
Yes,
Now
sir.
if I connect n identical cells in series, then equivalent EMF, equivalent
EMF.
EMF, E equivalent is equal to N into E.
Yes, sir.
Okay. Equivalent resistance R equivalent is equal to equivalent internal resistance
Yes, sir.
is NR.
Yes, sir.
Okay. So the main current, this I, main
Yes, sir.
current I is equal to we'll write NE by resistance is R, external resistance is R plus internal resistance is NR.
Mark. Yes, sir.
Okay.
Yes, sir.
Then potential across each resistance, potential across each resistance is potential across each each cell is V is equal to I into R.
R. Yes,
V is equal to IR.
yes, sir.
Potential difference across each cell is V is equal to IR.
R.
Okay. Now across the resistor,
Yes.
across the resistor. So across this one,
Yes, sir.
V is equal to IR.
IR. Yes, sir.
Okay. Across each cell is potential across each cell I will write now.
Yes, sir.
Potential across each cell is V dash is equal to V by N.
Yes, sir.
Power dissipated in the circuit. I would like to write power dissipated in the circuit.
Yes, sir.
How much power is dissipated in circuit? How much power will be dissipated in the circuit? P is equal to Ne by R plus NR. This is current.
Yes, sir.
P is equal to I square
I
into
R.
R.
Yes, sir.
P is equal to I square into R.
Yes, sir.
Now, the power dissipated in the circuit is P is equal to N E square
Mm.
by R. Now, condition for maximum power.
Yes, sir.
Condition for maximum
Power.
power. Now, if you want maximum power, then external resistance is equal to internal resistance. Then
Yes,
power dissipated is maximum, and that P max is equal to N into E square by 4R.
yes, sir.
P max is equal to E square by 4R.
Yes, sir.
This is grouping of cells.
Yes,
Okay,
sir.
when this is when you have identical.
Yes, sir.
Now I will write if they are non-identical and they are connected in series.
Series. Yes, sir.
Now the next concept is non-identical, non-identical connected in series.
Yes, sir.
Cells which are not identical but they are connected in
Series.
series. Now let us take one cell, another one connected in series like that. Many are there. You
Yes,
connect
sir.
to a resistor R. Let us take this one as E1. Internal
Mm.
resistance is R1.
R1.
E2, R2, E3,
R3. Yes, sir.
and this resistance is R3.
Yes, sir.
Then the equivalent EMF E equivalent is equal to E1 plus E2
E2.
plus
3.
E3.
Yes, sir.
Now current I is equal to E equivalent. E equivalent is E1 plus E2 plus E3
Yes,
by
sir.
R plus R equivalent.
R1. Yes, sir.
Okay, now R equivalent will be equal to R1 plus R2
R2
plus
plus R3.
R3.
Yes, sir.
Okay.
Yes, sir.
Then potential difference across each cell is V1 is equal to E1 minus I R1.
Yes,
Okay,
sir.
let us take this current as I.
Yes, sir.
And V2 is equal to E2 minus I R2 and
R2.
so on.
Yes, sir.
We can write.
Yes, sir.
Now here I will write this one wrongly connected
Yes, sir.
cells, wrongly connected. Now if you are connecting wrongly, then this like this, then you have a resistor R here and this is even internal resistance is
R.
R1. This is E2. Internal resistance
Yes,
is
R2.
R2. Then
Yes,
equivalent EMF will be E equivalent is equal to E1 minus E2.
yes, sir.
Current I is equal to
Mm.
E1 minus E2 by R plus R
R equivalent.
equivalent.
Yes, sir.
Now here because these are wrongly connected. Wrongly
Yes, sir.
connected means the negative terminal is connected to negative
Yeah,
terminal.
negative.
So
Yes,
yeah, R equivalent will be equal to R1 plus R2 here.
R2 plus. Yes, sir.
R1 plus R2.
R.
Even if
Yes,
it
sir.
is wrongly connected, the value of R equivalent will be R1 plus R2. Then we write uh, if cell 1 is discharging,
Yes, sir.
yeah, so we
Cell
write V1 is equal to E1 minus I R1.
R1. Yes,
We
sir.
take this as discharging,
Yes, sir.
and V2 is equal to E2
E2 minus
minus
IR2.
E2 plus IR2. Why? Because one is discharging, other one is
Charging.
charging.
Yes, sir.
This is when non-identical cells are connected in series.
Yes, sir.
Now I would like to discuss parallel grouping. We'll introduce the concept of parallel grouping. Parallel grouping
Yes, sir.
of cells. In parallel grouping, we'll have cells like this connected to external resistance. Now this resistance is R,
Yes,
this
sir.
current is I. Now this is E and internal resistance is R. This is E, internal resistance is R. This is E, internal
Mm-hmm.
resistance is R.
R. Yes, sir.
Then we write here identical cells are connected in parallel.
Yes, sir.
Okay, identical cells connected in parallel.
Yes, sir.
First, I'll take identical and then I will take non-identical. Okay.
Yes, sir.
So now in identical cells, when they were connected in parallel, then the equivalent E equivalent is equal to E.
Yes, sir.
Okay. And as the internal resistance, there it is parallel. So the internal resistance R equivalent is equal to R by
By N.
N.
Yes, sir.
Okay, the current I is equal to E equivalent by external resistance is R,
R.
R plus
R
R,
by N.
R equivalent. So this is E by
By R
R
plus
plus
R by N.
R by N.
Yes, sir.
Okay.
Yes, sir.
Now potential difference across external resistance. Across external resistance V across external resistance
Yes, sir.
V across external resistance is V is equal to IR
Yes, sir.
across external
Resistance.
resistance. Current from each cell. Next point is current from each cell. Current from
Each.
each cell. Current from each cell I dash is equal to I by N.
Yes, sir.
Okay. Then, right, power dissipated. Power dissipated will be equal to P. P is equal to I square R E
I
by
square. Yes, sir.
R plus
R
R
by
by
N
N
whole square
whole
into
square
R.
into R. Power dissipated in this circuit is this.
Sir, parallel లో V square by R తీసుకుంటారు సార్.
You can write like this also.
Yes, sir.
Okay.
Yes, sir.
Now, condition for maximum power dissipation.
Yes, sir.
Condition for
Maximum
maximum
power dissipation.
power dissipation is external resistance is equal to internal resistance
Yes, sir.
R by N.
N. Yes, sir.
So the power maximum power is equal to N into E square by 4R.
Yes, sir.
Okay. Right. This is for identical cells when they were connected in
Parallel.
parallel. Now
Yes, sir.
I will discuss, then we will discuss when they were non-identical, if they are connected in parallel.
Yes, sir.
Now, non-identical cells, non-identical cells connected in parallel.
Yes, sir.
So if you connect non-identical cells, let us take this one as E1
Yes, sir.
and this one as R1 and this as E2 and this cell as R2.
Yes, sir.
Now you connect them to the external resistance.
Yes, sir.
Then the current which was going here is I. This resistance is R.
R.
E equivalent is equal to E1 R2 plus E2 R1 by R1 plus R2. That is equivalent EMF.
Yes, sir.
Okay, when you have connected
In parallel.
in parallel,
Yes,
non-identical when we are connecting, then
parallel.
we
Yes,
uh, then we get E1 R2 plus E2 R1 by R1
R
plus
plus
R2.
R2. Yes, sir.
Then current I is equal to E equivalent by now R plus R plus R
Equivalent.
equivalent.
Yes, sir.
Okay.
Yes, sir.
Now R
R equivalent
equivalent
is R1 plus R.
1 by R1 parallel, right?
Yes, sir. Yes, sir.
1 by R2. They are parallel now.
Yes,
Here,
sir.
if they are in series, then R equivalent is equal to R1 plus
R1 plus R2.
R2.
Yes, sir.
Then current from each cell is I1 is equal to E1 minus
I1.
IR by R1, and I2 is equal to, okay, I1
Yes.
is here and I2 is here, and I1 plus I2 will be equal to I.
Yes, sir.
That is equal to
E2
E2
minus
minus
ER
IR by
I R2.
R2.
Yes, sir.
Okay. Now
Yes.
this is when non-identical cells connected in parallel.
Parallel.
Now
Yes, sir.
if they were connected in wrongly connected, if they were
Yes.
wrongly connected, if they were wrongly connected, wrongly connected. Wrongly connected means now
Negative.
this here it will be like this. Okay, positive connected to negative here. Okay, like this. Okay.
Yes,
Now
sir.
this is connected to an external resistor. That external resistor resistance is R.
Uh, yes, sir.
Let us take this is E1. Internal resistance is R1.
Yes,
This is E2. Internal resistance is
R2.
R2.
Yes, sir.
And this is
I1.
I1. And
I
this is
I2.
I2.
Yes, sir.
And the current here is
I.
I.
Yes, sir.
Now equivalent EMF, E equivalent is equal to E1 R2
Yes, sir.
minus, so here you have plus because they were connected.
Yes, sir.
Likewise, they correctly, if you wrongly connected, then E1 R2
Minus
minus
E2 R1
E2 R1
by
by
R1 plus
R1 plus R2.
R2. Yes, sir.
That is E equivalent.
Yes, sir.
Okay. R
Yes,
equivalent will be 1 by R1 plus 1 by R2.
yes, sir.
Okay. So remaining will be same. R equivalent will be equal to, for wrongly connected also, you will get 1 by R1 plus
1 by
1 by
R2.
R2. And I is equal to E equivalent by R plus R
R
equivalent. But
equivalent. Yes,
E equivalent value is going to
change.
change here.
Yes, sir.
Okay.
Yes,
So
sir.
when the cells are wrongly connected, I mean connected in reverse polarity, generally we call this as connected in reverse
Yes,
polarity.
yes, sir.
Then we are going to get these equations.
Yes, sir.
Okay.
Yes, sir.
Then we have mixed grouping of cells. Okay, mixed grouping of cells. Now here I will write mixed grouping of cells. Mixed grouping. Here we connect both in series as well as parallel. Mixed
Yes, sir.
grouping of
Cell.
cells. Okay, both we connect them in series as well as parallel.
Yes, sir.
Now, now let's take a circuit. Okay, so on.
Yes, sir.
Okay, and like this we take second one here, 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 so
Yes,
on, like this. Like this we can, we have many rows like
yes,
this,
yes,
and
sir.
then you have a resistance here.
Yes, sir.
Now for this we have to calculate the current. Okay, now E1, let us take this is E2,
E
so on, and this is
EN.
En.
Yes, sir.
Okay, this is second, like that. Em rows are there.
Yes, sir.
Okay, let us take them as identical. Okay, these are all identical cells.
Yes, sir.
So I will write E1 E1 only like that. Okay, similar cells. M rows are there. Okay, and
Yes, sir.
N are there. Okay, in each row N are there.
Yes, sir.
Okay, N identical cells are connected in a row.
EM rows.
Like that
Yes,
M rows are there.
yes,
Okay,
sir. Yes,
then
sir.
I now first I'm taking identical. So what I've done is I took identical one. In each one, n cells are there. Like that, M I have connected. Okay.
Yes, sir.
Now here, E equivalent will be equal to Ne,
N. Yes,
n
sir.
into E.
Yes, sir.
Okay. Then R equivalent,
R
R
equivalent.
equivalent is equal to, now this is this each, for each one internal resistance is R. For each one
Yes, sir.
internal resistance is R. So for this many you will get NR.
Yes, sir. NR. Yes, sir.
Like that M are there. So M are in parallel. So NR by M
M.
is
Yes, sir.
R equivalent.
Yes, sir.
Now the current flowing is I. I is equal to E equivalent by external resistance is R.
R.
R
Yeah.
plus R equivalent. That
NR by
is
N.
equal to, yeah, NE by
NE by R
Ne
plus
by R plus R
NR
equivalent
by M.
is
NR
NR by
M.
small m.
Yes, sir.
That gives the total current.
Yes, sir.
Okay. Now here is the potential difference, that
Yes,
is
sir.
V1, and that V1 will be equal to I
I
into
into R.
R.
Yes, sir.
Now potential difference across each cell V dash is equal to V by N.
By N.
V
Yes,
by
sir.
N is potential difference across each cell.
Yes, sir.
Each cell V dash is equal to V by N.
N. Yes, sir.
Current from each cell. Current from each cell I dash is equal to I by N.
By N. Yes, sir.
What is this?
Current from each cell.
Current from
Each
each
cell. Cell.
each cell.
Yes, sir.
Okay.
Yes, sir.
Now condition for maximum power. So
Yes,
we have maximum power when we have external resistance R
R.
is equal to internal resistance. Internal resistance is NR by
By M.
M.
Yes, sir.
So this maximum power is equal to Mn is total number of cells
Yes, sir.
into E square by 4R.
Yes, sir.
R is internal resistance of each cell.
Cell. Yes, sir.
Again. Okay. Now the total number of total number of cells is total
Number of cells.
number of cells is M into N.
N. Yes,
Mn
sir.
is the total
Yes,
number of
cell.
cells. Mn is the total number of cells, the mixed
Yes, sir.
grouping. Okay.
Yes, sir.
So these are the mixed grouping of cells.
Cell. Yes, sir.
Okay. Now, next concept is
Kirchhoff.
Kirchhoff's laws.
Yes, sir.
Basically, we have two laws. One is Kirchhoff first law. Now, Kirchhoff's first law is also called as the junction rule.
Yes, sir.
Junction rule or law. Junction law also you can say,
Yes, sir.
or or current law,
Yes, sir.
or else this is called as current law, or Kirchhoff current law, KCL.
Yes, sir.
Kirchhoff current law.
Law. Yes,
This is this is based on conservation of charge.
yes, sir.
Based on conservation of
Chart.
charge. Okay.
Yes, sir.
Now, what the statement is, the algebraic sum of currents meeting at the junction is zero.
Yes, sir.
The algebraic algebraic
Some more current
sum of currents at the junction
is zero. Yes, sir.
at the junction is zero.
Yes, sir.
What is the algebraic sum of the current? Sigma I is equal to zero.
Zero. Yes, sir.
Sigma I, the sum of all the currents at the junction is equal to
Zero.
0.
Yes, sir.
So now let us see how it is. Say there is a current here and
Yes,
the current here in another wire. Let us take this is I1 and this is I2
sir.
and the current is flowing like this and this is I3. Now
Yes,
here the sum of the currents flowing in should be equal to sum of the currents flowing out.
I three. Yes,
So
sir.
I1 plus I2 minus I3 is equal to 0 because sum of the currents is equal to 0.
Yes, sir.
So we can write I1 plus I2 is equal to
Equal to I three.
I3.
Yes, sir.
Okay.
Yes, sir.
So now here you can solve a problem like this. Say so this is like 4 amperes. Now here you have 1 ampere.
Yes, sir.
Here this is 2 amperes. This is branching out. This is 1 ampere. And here how much current is passing. Now this is 4 amperes. So this is 1 ampere and this is going to be 3 amperes because at the junction
Yes,
current
sir.
flowing in should be equal to current flowing out.
Yes,
So
sir.
this is 4 amperes is coming in. So 1 ampere and 3 amperes. So this is 4 ampere. So
Ampere.
3
Yes,
amperes is coming in. 1 ampere is going out. Then here how much we will have? 1 ampere going out. So this is
2 amperes.
2 amperes.
Yes, sir.
Okay, we use junction at every junction law at every junction.
Yes,
Current coming in is 3 amperes. So current going out should be
3 amperes.
say 1 3. So already 1 is there. So here it should be
2
2
amperes.
2
Amperes.
amperes.
Yes, sir.
Okay.
Yes, sir.
Now next one is Kirchhoff second law. Kirchhoff's
Second.
second law. This Kirchhoff's second law is also called as loop law.
Yes, sir.
This is also called as loop law. or Kirchhoff voltage law.
Yes, sir.
Kirchhoff voltage law is K. We can also call this as KVL.
L. Yes, sir.
Okay. Now here the statement goes like this. The algebraic, now earlier it is current, now it is voltage. The
Voltage.
algebraic sum of voltages in a loop is equal to 0.
0.
The statement is the algebraic sum
Um,
of change in potentials,
yes, sir.
change in change in potentials around the closed loop,
Yes, sir.
around the
Close.
closed loop,
Yes, sir.
around the closed loop
Yes, sir.
is 0.
Yes, sir.
Sigma V is equal to
0.
sigma V is equal to
0.
0.
Yes, sir.
Okay.
Yes, sir.
Now I'll take a closed loop and just write the equations. Okay. How to apply this one in a closed loop. So now I will consider, say, a point. From this point I will write some resistance. Okay.
Yes,
Then here one more resistance. Here one cell. Then okay, let us name these points. Let us take this as A, this
yes,
point as B, this
B,
point as
B.
C,
Yes, sir.
point as D,
Yes, sir.
and then I'll have one more resistor here. Okay, so this one is E4.
Yes, sir.
Okay, then let us take this one more cell here,
Yes,
one more resistor like this. Now
yes,
let's call this, name these resistances. This resistance is, let us say this is
R.
R1.
Yes, sir.
Okay. Have a branch here. Now this resistance is R2.
Yes, sir.
Okay.
Yes, sir.
This is, say, let us take this as E1,
One.
and this is positive. This is negative.
Yes, sir. E2.
And this is, and
R3.
this resistance is R3,
Yes, sir.
and this is
E2.
E2.
Yes, sir.
Okay, this is positive terminal. This is negative terminal,
Yes,
and
sir.
you take this as E3.
E2. Yes,
And
sir.
this resistance is, say, some R4.
R4. Yes, sir.
Okay. Okay.
Yes, sir.
Then we can write the drop of the current. We will consider current moving in one direction. And
Yes, sir.
say, let us take this current is I1, R1. So let us take that current as I1. I will assume that current is in this direction, and then I will write the equations. Okay.
Yes, sir.
So yeah, okay, let us take this current as I1. So now this current here is I2.
Yes, sir.
Okay. So
Yes,
this is I3, and here it is
I4.
I4.
Yes, sir.
Okay.
Yes, sir.
So let us assume that current is flowing in this direction.
Yes,
Okay.
sir.
Right. So if the current is flowing in this direction, then resistance, I'll start from A, and then I will end up at A. This is a loop.
Yes,
Okay.
sir.
Now, what I'll do is I will consider this one. as current is flowing in this direction. So high, this is low,
Low. Yes, sir.
and this is high, and this is low.
Low.
This is high, this is low.
Low. Yes.
Positive terminal high,
High.
negative low.
Low. Yes,
This
sir.
is high, and this is
Low.
low. This is low, and this is high.
High. Yes,
Negative
sir.
terminal is low, positive terminal is high.
High.
Current is
Yes.
flowing in this direction, so this is high, this is low.
Low.
Now
Yes, sir.
when current is flowing from high to low,
Yes, sir.
if it is flowing, then I will take it as drop, potential drop.
Drop. Yes, sir.
So I'll just write the equation now. Look here. So I1, high to low means drop. So minus I1 R1.
Yes,
Now
sir.
here high to low, I2 R2 minus
No. I
I2
two R
R2
two.
because there
Yes,
is a drop.
yes, sir.
Now this is high, this is low. High to low drop. So minus
Minus
E1.
E1.
Then here I3 R3. High to
Yes,
low drop minus
minus I3
I3
R3.
R3. Then
High
here low to high
plus
plus
E2.
E2.
Yes, sir.
Then here low to high
Plus
plus
E3.
E3.
Yes, sir.
Then
High, high to low.
high to low. So
Minus I1.
minus I4
I4 R4.
R4 is
Yes,
equal to
0.
0 because
Yes,
sigma V is equal to
0.
0.
Yes, sir.
Okay. This is based on conservation of energy.
Yes, sir. Conservation.
This is based on conservation of energy.
Yes, sir.
Earlier one is based on Kirchhoff current law is
Yes, sir.
based on conservation of charge.
En
Here conservation of
energy.
energy.
Yes, sir.
Okay.
Yes, sir.
That is Kirchhoff
Law.
voltage law.
Yes, sir.
Okay. Now I will explain one problem based on this.
Yes, sir.
Okay. Uh, Kirchhoff Kirchhoff law.
Yes, sir.
Okay, on this one, and we will do one problem based on this and one problem based on loop law.
Yes, sir.
Now, E1 is equal to 4 volts.
Yes, sir.
R1 is equal to 2 ohms.
Yes, sir.
E2 is equal to 6 volts.
Yes, sir.
R2 is equal to 2 ohms. And R3 is equal to 4 ohms. Okay, the current in I1 is
Yes, sir.
current in I1 is how much? Now that's
Yes,
the question.
yes, sir.
E1, R1, E2, R2,
R
R3, current in I1. Now I
I1.
will give the circuit. The circuit is like this. Now let us take this as E1.
E1. Yes, sir.
This is
R1.
R1. This
R
is R2. This is E2.
R3.
And this is
R3.
R3.
Yes, sir.
Now current going is
I.
I1. In
Yes,
this
sir.
loop, it is I1.
Yes, sir.
In this loop, current here it is It is I2. Okay.
Yes, sir.
R2, R3 is 4 ohm from the data. R2
Yes,
is 2 ohm.
2
So
ohms.
we write it here. R1 is how much?
2 ohms.
2 ohms. E1 is
4 volts.
4 volts. E2
E2 is
is
6 volts.
6 volts. Okay.
Yes, sir.
Now, what I'll do is I will take two loops. Here, this is loop
1,
1, and I will
sir.
consider this as loop 2.
2. Yes, sir.
Okay. Now
Yes, sir.
here current will be moving in opposite direction. Current here is moving. This is I1. This
Yes,
is
sir.
I2.
I2.
So
Yes, sir.
current in this net current flowing through the 2 ohm is I1 minus
I2.
I2 is the net current flowing through R2.
Yes, sir.
Okay. Now for loop 1 we will write equation. Loop 1. I'm
Yes, sir.
writing equation for loop 1.
Yes, sir.
For loop 1 we will start here
Yes, sir.
and I will end up here.
Yes, sir.
Okay. So this is low and
Low,
this is
high,
high. So low to high.
plus.
Potential gain.
Yes, sir.
Low to high. From low to
Too
gain.
high. Yes, sir.
High
Plus
means
E1.
jumping. From low
Yes,
to high jumping. That means potential increased.
gain. Yes, sir.
So I will write E1.
E1. Yes, sir.
Okay.
Yes, sir.
E1 for loop 1. E1. Then here current is moving in this direction. So this is high, this is low. There is potential drop. Potential
Drop
drop
minus
is minus
R1,
I1
I1, R1.
into 2,
Yes, sir.
right?
Yes,
And
sir.
here I1 minus I2. Current is traveling in this direction. So this is high, this is low, drop. So
Yes.
minus I1 minus I2 into
2,
R.
2,
Resistance is 2
2. Yes, sir.
is equal to 0.
Equal to. Yes,
This
sir.
is sigma V is equal to 0. Loop 1.
Yes.
Now loop 2. Loop 2.
Yes, sir.
For loop 2. Loop 1. For loop 2.
Yes, sir.
Ah, let's write the equation for loop 2. Loop 2. I will start from here.
Yes, sir.
Now this is low. This
Low,
is
high.
high. So it gained
Plus, plus, sir. Yes, sir.
plus. So this is
E2. E2.
E2.
Yes, sir.
From this direction, this is low, this is high. So this is plus.
Up. I1 minus
Plus 2 into I1 minus
I2.
I2.
Yes, sir.
And
E1.
here now the current will flow like this. So
Yes,
this
sir.
is high, this is
Too
low.
low.
So there
Yes,
is a drop in potential. So
minus
minus the current is I2 and the
I2.
resistance is 4,
4
right?
ohm. Yes, sir.
That is
Is
equal
equal to
to
0.
0.
0.
You
Yes,
got
sir.
equation 1, got equation
2.
2.
Yes, sir.
Okay, solve those equations. Solving. Now,
Equation.
due to this space constraint, I'm not solving exactly here. Let's
Yes, sir.
solve. If you solve here,
Yes, sir.
then we get I1 is equal to 1.8,
Yes, sir.
1.8 ampere,
Yes, sir.
and I2 will be equal to 1.6 ampere.
Yes, sir.
Okay, so
Yes, sir.
this is loop law,
Yes, sir.
based on loop law.
Yes, sir.
Okay.
Yes, sir.
Okay. I'll just do one more problem. Now there is a circuit here. This is 10 volt,
Yes,
and
sir.
this is 2 ohm,
Um,
and here you have 5 volt, and this is 3 3
um,
ohm.
3. Yes, sir.
Okay. Now let's write the Kirchhoff voltage law here. Okay. Now here this is okay, 5 volts. Now this is high, this is low.
No.
This
Yes,
is, let us assume that current is moving in this direction. One
yes,
loop is there. So this is high, this is
high,
low. Let us
low.
assume that current is flowing in this direction. Okay.
Yes, sir.
So yeah, so
High,
this is high, this is
low.
low, this is low, this is
High.
high.
Yes, sir.
Now here you see high to low. High
Yes, sir.
to low means
Potential drop.
potential drop. Potential
Minus.
drop is
Yes,
minus 10, and
minus 10.
here high to low minus
Minus 2 into I.
I.
Yes, sir.
High to low
Minus 3 into I.
minus 3 into I.
Into I
Low to high
plus
plus
5.
5
Yes, sir.
is equal to 0,
Yes, sir.
right? So this is minus 2i minus 3i minus
Minus
5i
4I minus
minus 5 is
minus
equal to 0.
0.
Minus 5i is equal to
5.
5. That
I
means
is
I
equal
is equal to 1
to 1.
ampere. Okay.
Yes, sir.
Now you may
Yes,
say, okay, sir, minus 1. Minus 1 denotes that loop current is in opposite direction.
yes, sir.
Minus 1 magnitude wise, it is only 1
1
ampere.
ampere.
Okay.
Yes,
Now that means the current direction is opposite. I should have taken opposite direction.
yes,
Okay.
sir.
So this is 10 volts, this is 5 volts. Obviously current is in opposite direction.
Yes, sir.
Okay. If you get negative, that means you have taken current in opposite
Direction.
direction.
Yes, sir.
So the current here is
1 ampere. So minus indicate
1.
anti-clockwise direction. Sir, no.
No, no. Whatever direction you took, that opposite direction, that's it.
Yes, yes, sir.
Okay.
Yes, sir.
Right. Okay. Now this we can calculate by using the other method also. Let us take other method and I'll show you how to solve it in another method. Like the E net you calculate here, E net. Okay, now they were wrongly connected here. So this is 10, this is 5. So the net EMF is equal to 10 minus 5. That is equal to 5 volts.
Yes, sir.
Okay, and this is second method. E net is equal 10 minus 5. That is equal to 5 volts. Now the total resistance is
I.
R equivalent is equal to 2 plus 3. That is equal to 5 ohm.
Yes,
So
sir.
I is equal to E net by R
R.
equivalent.
R.
So
Yes, sir.
that is equal to 5 by 5. That is equal to 1 ampere. Like this also you can solve. Okay,
Yes,
this is based on loop law. This is calculating the net E net and R net, and I is equal to E net by R equivalent.
yes, sir.
Anyway, you can solve the problem.
Yes, sir.
Okay.